This session's primary objectives are to recognize the coherence of multiplication and division and how it builds across the grade levels, and to study the sequence of multiplication and division to increase our content knowledge. Please take out your personal whiteboards and your place value discs. We are going to model a 1-digit times 2-digit multiplication problem on a place value chart with our discs. Let's draw a place value chart that has only ones and tens. And we're going to solve the problem 3 groups times 23. Is what in unit form? That's right, 2 tens, 3 ones. So represent 23 on your place value chart. Now let's represent 2 more groups of 23 on our place value chart with our discs. Let's find the total value of our ones. 3 groups of 3 ones. We can write underneath that that's 3 times 3 ones. And that's how many ones? That's right, 9 ones. So we can write 9 ones. We're also going to write this in the vertical algorithm. So 3 groups of 23 in the vertical algorithm. I like to write my work along the side. 3 times 3 ones. Eventually your students will grow out of having to do that. I do like to do that at the beginning. And that's 9. Let's look at the tens place. We have 3 groups of 2 tens. Underneath our tens column, we can write 3 times 2 tens. And 3 times 2 tens is 6 tens. Let's show that on our vertical algorithm. Our work is 3 times 2 tens. 3 times 2 tens is 6 tens, but what is that in standard form? That's right, it's 60. Let's find the total value of all of our discs. 6 tens plus 9 ones equals 69. And then in our vertical algorithm, 9 plus 60 is 69. So you see that we add the 2 rows underneath our line to get our product, which is 69. Okay. This is one way to solve using a place value chart and place value discs. Notice that I did not label that this is the tens column and this is the ones column, because my place value discs have the values right on them. So I don't need to label my columns. That's the convention for Eureka, is that if you're using this type of model, you don't need to label the columns. However, on this type of model, the columns are labeled because we are not going to have the values on our discs. We're going to try now the chip model. We already solved number 1 on our personal whiteboards. We're going to solve number 2. 4 groups of 34. Using the CHIP model. The CHIP model involves dots to represent place value discs. So what is 34 in unit form? Yes, 3 10s, 4 1s. Represent 34 on your place value chart. I'm solving the problem 4 groups of 34. So show 3 more groups of 34 on your place value chart. Let's find the total value of our ones. 4 groups of 4 ones is 16 ones. And the value of our tens, 4 groups of 3 10s is 12 tens. We're about ready to add our 12 tens and our 16 ones. Is there anything that needs to be regrouped? Yes, we need to bundle 10 ones to make 1 10. And we need to bundle 10 10s to make 100. Now these values need to be changed. We no longer have 16 ones. We have how many ones? Yeah, 6 ones. And we no longer have 12 tens. How many tens do we have? 3 tens. And of course now we have 100. Let's show this with a vertical algorithm along the side. 4 groups of 34. I'm going to show my work here. 4 times 4 ones is how many ones? That's right, 16. 4 times 3 10s is 12 tens. But 12 tens in standard form is written how? That's right, 120. Let's find the total using our place value discs first. 100 plus 3 10s plus 6 ones equals, yes, 136. And then let's find the total in our standard algorithm, vertical algorithm. 6 ones, 3 10s, 100. So our product is 136. This is called the CHIP model. I've showed you both the concrete model and the CHIP model. The CHIP model allows the students to move from concrete into the pictorial representation. And alongside we have the vertical algorithm. Next, I would like you to try independently 4 groups of 424, also using the CHIP model.